Hello everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, I will be taking you through part 2 for university calculus. And in this session, we will be talking about the derivative of a trigonometric function, ladies and gentlemen. Right. In part 1, we went through what is called the product and quotient rule, where we looked on how to find the derivative of a function when two functions are being multiplied to each other, which we call it a product rule. And also when we are dealing with quotient or ratios that are in the form of a fraction, like when we have f over g, then we can be able to find the derivative when we're having quotient. That is what we have done in the first part. And within this part, we also went through the derivative of a natural exponential function, where we said the derivative of e to the exponent of x is just e to the exponent of x. That is what we went through, ladies and gentlemen. And again, we also went through the pre-knowledge, which is actually called the rules of differentiation, what you have learned in grade 12, together with the first principles, because we use them to prove some of the things here. And ladies and gentlemen, we went through what is called the application using product rule and quotient rule. We solve problems relating to product rule and quotient rule. Kindly, if you have not watched the video for the product and the quotient rule, you can, there's a link that I've shared below. Kindly follow the link and don't forget to like, subscribe, and hit the bell button for future video updates. Right now, however, in part 2, we'll be talking about the derivative of trigonometric function. How can we find the derivative of trig functions? For example, if we have y equals to sine x, we wanted to know what is the derivative of y with respect to x of sine x. Obviously, we'll be proving this, that the derivative of sine x equals to cos x. So we'll be talking about this, ladies and gentlemen. But however, in understanding the derivative of function, of trigonometric function, we need to familiarize ourselves with what we have learned in grade 12, also in grade 10 and 11. Things like trigonometric ratios. You need to familiarize yourself with the trigonometric ratios and their reciprocals. Let's talk about the trigonometric ratios and their reciprocal. This is a prerequisite. You need to be able to understand this. Trigonometric ratios. This is what you have learned in grade 10, 11, and also even 12 together with their reciprocal. Right, let's start with the trigonometric ratios, ladies and gentlemen. Number 1, we have a trig ratio for sine. We know that sine of theta, I'll just use theta, and the cos of theta and tan of theta. These are the three trigonometric ratios that you need to be able to understand. We know that in terms of, we call them the ratios because they can be written in the form of a fraction, numerator and denominator. And we know from these that these are called SOHCAHTOA, but it's not necessary for now to use this because we know sine, it's opposite over hypotenuse, then the cos of an angle is adjacent over hypotenuse, and the tan of an angle is opposite over adjacent. But we are not interested on that for now. We're not interested on this. We're just interested on knowing the trigonometric ratios. In the first one, we have sine, cos, and tan. This is sine, cosine, and tangent, which is, in short, we call it tan. Then now, these ratios has what you call the reciprocals. Reciprocals actually, it's called the reciprocals. And reciprocal are just the opposites of this actually. Like if you say, what is the reciprocal of x? Obvious, the reciprocal of x is 1 over x. So this is called the reciprocal. So now, then now the reciprocal of sine. Sine has its reciprocal, and the reciprocal of sine is called the cosec. So cosec theta. Cosec is the reciprocal of sine, and cosec is the same as 1 over sine. Is the same as 1 over sine. Remember, in most of the scientific calculators, we do not have this reciprocal. For example, if we say to you, calculate the cosec of 30, remember, you cannot calculate this from your calculator. You do not have it. You only have sine, cos, and tan, which means to get the cosec of 30, that will be 1 over sine 30. 1 over sine 30. So this is an example of a reciprocal. So it means if we know that sine 30 from the calculator, it's a half, which means the cosec of 30 will be 2. Will be 2 because it's just the reciprocal of sine. So you need to be able to know that the reciprocal of sine is cosec, and a reciprocal of cos it's sec, which is secant. So we have sine, and its reciprocal is cosecant, which is cosec. Then we have cosine, and its reciprocal is a secant. It's a secant. Then we also have tangent, and its reciprocal is cotangent. It's called a cotangent. In short, it's called cot theta. So which means that if we are saying sine its reciprocal, it's sec, it means sec is the same as 1 over cos theta. Whereas the reciprocal of tan, it's cot, which means cot is actually 1 over tan. 1 over tan. So these are very, very, very important, ladies and gentlemen. We call them the reciprocal. We know in grade 12, you were not talking about this reciprocal, but now you need to be able to understand them. Remember, at the university level, they are not reminding you of these things. Unless if you're going to do a bridging course, then they will first take you through these basics. But make sure that you understand these, ladies and gentlemen. So we know that from now, sine has its reciprocal, which is called cosec, and cos has its reciprocal, which is called sec, and tan has its reciprocal, which is called cot. And it's very important for you to be able to know this. Particularly in some instances, you find that they want you to calculate values using this reciprocal. And from most of the scientific calculators, they do not actually show this. They only show sine, tan, and cos. Tan and cos. So which means, for example, if you were asked to calculate, let's say, you were asked to calculate the sec of 30. Obviously, we do not have sec on the scientific calculator. I apologize for saying financial calculator. So because of this, it means if you want to calculate sec of 30, sec is the reciprocal of cos, which means this is the same as 1 over cos of 30. So it means you can either calculate 1 over cos 30 and it will give you the answer. Very, 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 very important, ladies and gentlemen. You need to familiarize yourself with the trigonometric ratios together with its reciprocals. Then the second one, it is the issue of knowing what is called the identities, trigonometric identities. You have learned this from grade 12. The first one, especially when you talk about the identities, we have something called a squared identities, something called a squared identities, and the second one is called the quotient identities. So it means these are the ones that are written in the form of a fraction. So you have learned these in grade 12. But however, in the context of a squared identities, the one that you focused more is that one of saying sine squared of an angle plus cos squared of an angle. This is equals to 1. It is equals to 1, ladies and gentlemen. It is an expression that is been proven to be true. It is proved that sine squared theta plus cos squared theta equals to 1. That is called a squared identity. And there is another one which I will introduce now because you need to be able to know this. It was not addressed in grade 12, but now you need to know it. That says when you take 1 plus the tan squared of an angle, this is equals to the sec squared theta. It was taken out because it's now using the reciprocal, and however, in your syllabus in grade 12, reciprocal were not covered. That's why they did not include it. So during our time when we're doing high grade, they were actually addressing this. So it's very, 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 very important for you to know these trigonometric identities. So we have the squared identities, which says that sine squared theta plus cos squared theta equals to 1. And 1 plus tan squared theta equals to sec squared theta. Let me prove this one first to prove to you why are we saying 1 plus tan squared theta equals to sec squared theta. I want to prove this to you, ladies and gentlemen. Let's say we have 1 plus tan squared theta. This is equal to the sec squared theta. We want to prove this. Let's start with the left-hand side. Remember, when we are proving this, we start with any side that is complicated. Obviously, we're going to have 1 plus tan squared theta. We can do these in 2 ways. We can actually do this in 2 ways. Before I prove this, let me talk about what is this? Let me talk about a quotient identities. Let me talk about the quotient identities, right? A quotient are those that are written in the form of a fraction. And the first one, you have learned this in grade 12, it says the tan of any angle is equals to sine over cos. The tan of any angle is equals to tan over cos. That's why in grade 12, there is this thing where we said if tan equals sine over cos, then it means 1 over tan. 1 over tan, it is the one that is cos over sine. So which means, as we said tan as the reciprocal, and its reciprocal, it's cot. And we know that the cot is 1 over tan. The cot is 1 over tan, which means cot is the one that is equals to cos over sine. The cot is the one which is cos over sine, because cot is 1 over tan. So it's very important, guys, to familiarize yourself with with the reciprocals. Then now we want to prove this. I'm going to say 1 plus. By the way, we know that tan, it's sine over cos. We know that tan is sine over cos. Obvious, if tan is sine over cos, which means tan squared theta, it will be sine squared theta over cos squared theta. Then we can now simplify fractions. I believe you know how to simplify fraction. Let's now simplify fractions. We know when we are simplifying fraction, if we have 1 over 3 plus, let's say, 7 over 2, what we do, we multiply the denominators. So it's 3 times 2, which gives us 6. Then we multiply this first. 1 times 2 is 2, plus then we multiply that 7, which is 21, which will give us 23 out of 6. So now we're going to do the same here, ladies and gentlemen. It's algebra. So we're going to do the same. We'll multiply the denominators together. When we multiply the denominators together, we're going to multiply 1 together with cos squared. This will give us cos squared theta. Then we cross multiply here. 1 times cos squared theta. This is cos squared theta plus 1 times sine squared. This is sine squared theta. But look at the numerator. We have cos squared theta plus sine squared, which is this one. And we know that sine squared theta plus cos squared theta is 1. So this will become 1 over cos squared theta. But look at this. We know that sec of theta, it's just 1 over cos. Sec of theta, it's 1 over cos. But now we know that, remember, cos, sec is a reciprocal of cos. So which means if it's sec squared theta, this will become d squared, which will just be 1 over cos squared theta. You see, this is cos squared theta. So it means this is the same as sec squared theta. So we've proved that 1 plus tan squared theta equals to sec squared theta. So it's very important, ladies and gentlemen, to know these things. Very, 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 very important. I mean, if you want to enjoy university maths, if you want to enjoy university mathematics, ladies and gentlemen, you need to be able to understand this. I don't want to frighten you, and I'm just actually showing you that you need to be able to know these things. You need to actually understand this for you to enjoy the university mathematics. Right. You know, these things actually, especially the issue of knowing the trig ratios and its reciprocal, knowing the squared identities, it's very, 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 very important. And one other thing, guys, is the issue of being able to familiarize yourself with the issue of compound angles, compound and double angles. Let me just say compound and double angles, the one that you learned in grade 12, compound and double angles. So these are also relevant also. And again, from what we have covered, the issue of first principles, you need to make sure that you familiarize yourself with first principle formula. We went through this in the first part, ladies and gentlemen. So it's very, 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 very important to be able to know this pre-knowledge, what you have learned in grade 12. Number 1, we spoke about trigonometric ratio, which is sine, cos, and tan. And also we spoke about its reciprocals. Remember we said the reciprocal for sine, it's cosec. And the reciprocal of cos, it's sec. And the reciprocal of tan, it's cot, which is just 1 over the trigonometric ratios. So it's very important for you to be able to understand these trig ratios, ladies and gentlemen. All right. Now we can move on to the derivative. Now, it means, ladies and gentlemen, we need to be able to know this, to say, for example, according to this definition, they're saying when you are making the derivative of a function, trigonometric functions, number 1, it says the derivative of sine is cos, and the derivative of cos it's negative sine, and the derivative of tan it's sec squared x. The derivative of cosec it's negative cosec x times cot x. Derivative of sec it's sec x multiplied by tan x, and derivative of cot it's negative cosec squared x. Remember, we need to be able to understand why are they saying the derivative of sine is cos, the derivative of cos is negative sine, the derivative of tan it's negative sec squared x, and so forth. Now, before I prove all of these, ladies and gentlemen, I want us to introduce one aspect about the limits, There are two concepts that you need to know about limits where we are using trigonometric ratios, because we'll be talking about this. The first one says that the limit when theta approaches 0, the limit as theta approaches 0, the more it comes closer and closer to 0, the sine of theta over theta becomes 1. So this is according to the limit. Say the limit as theta approaches 0 or tends to 0, sine theta over theta becomes 1. This is according to the limits. And the second one says the limit as theta approaches 0, cos of theta minus 1 over theta, in terms of absolute value, this becomes 0. But we'll talk more about that. Don't worry about that. So this is what we need to know, that the limit when theta approaches 0 of sine theta over theta, this becomes 1. But the limit when theta approaches 0 of cos theta minus 1 over theta, this becomes 0. So this is what we actually want to prove. I want us to do this using the program to actually prove that sine, the limit when theta approaches 0, it can be theta or h, does not matter. When approaches 0, sine theta over theta becomes 1. And the limit when cos theta, when theta approaches 0, the cos of theta minus 1 over theta becomes 0. Let us prove this practically. So let's prove this practically. So I'll just do the way like what we have done earlier when we were proving that the limit when h approaches 0 of e to the exponent of h minus 1 over h, this becomes 1. This is what we have proved using Python program. Then we're still gonna do the same to prove for sine and to prove for cos. Right, without wasting time, let's now go to the program. Right, here it's my program. Okay, so here it's my program, ladies and gentlemen. On the first part already we went through, we proved this. You remember we proved this practical to say the limit when h approaches 0, e to the exponent of h minus 1 minus divide by h, this gives us 1. So I will do this. This is the Python libraries, NumPy and Pandas, and together with the matplotlib and the Seaborn for visualization. So I'll run this because we'll be using them. Right, then this is what we have done. We have generated numbers from 0.5 up until 0.01. Then within this, then we computed the values. So it means when there is a h here, we substitute by those values, then to compute the values. Now you can see this is what we got earlier, but this is what we have done in part 1. But now we want us to move on to the part 2. Let's just wait for it to finish to import the libraries, that we'll just use them for visualization. Right, and then while it's still running fine, okay, this is what we went through when we spoke about the exponential, to say we've seen that as age from 0.5, as age approaches 0, the more it comes closer to 0, then the function gives us approaches 1, becomes 1 as the value. So this is what we want to experiment on the sine and the cos, but this was just for an exponential function. Ladies and gentlemen, let me check if it has completed the running or is still taking some time. I just don't know why is it taking a lot of time, because it was supposed to compute it fast, but it's fine. Let's just check the kernel. The kernel is still busy. Right, it has completed the program. Right, here we want to observe that one for cos. Let me just run this. You see, this is what you want to check. We want to check that the limit when h approaches 0 of cos h minus 1 over h. What is the answer? Okay, fine. This is what I have. This is just a function that I've actually defined for a cos. Then now with those values of h that I've computed from 0.5 up until 0.01, then here is the function. This is the function. This is the same function that I'm actually computing here. Let's run this one. Now let's call the function to compute those 20 iterations. And then now I'll just display the values here. Let's now look at this. So you see that this is the cos of the function. Like, let me just do this. Right, you can easily see that when we look at the function, let me just write the function again. According to the function, it says the limit when h approaches 0 of cos of h minus 1 over h. What will be the result here? Let's come down here. Look at these values, guys. Look at the values. Look here. Initially, you can easily see that when h is 0.5, the cos of this value is now giving us 0.24. But when it's getting decreased, remember the values of h is getting decreased, and the more these values of h decreases, maybe up until we have 0.0001. You see that when it's 0.001, the value actually, it's closer to 0. You see that the h is actually approaching 0. So we see that when h is actually approaching 0, what is the output here? The output is actually giving us 0. So what does it mean? It means that the more the limit when h approaches 0 of cos of h minus 1 over h, then cos of h minus 1 over h, this becomes 0. This is what we have seen there. So it's showing that the more h, when h approaches 0, then the cos of h minus 1 over h, it becomes 0. So we have proved that the limit when h approaches 0 of cos of h minus 1 over h, it becomes 0. So we have got that. So now, which means now we can conclude that the limit when h approaches 0, cos of h minus 1 over h, this becomes 0. This becomes 0. I believe you are following, ladies and gentlemen. I believe you are following, ladies and gentlemen. We can even compute this graphically. Okay, let me just copy the function. Let me just copy this function here so that I can be able to display it there. Okay, let me just copy the function. I wanted to display this graphically, ladies and gentlemen. Okay, right, let me just paste it there. Okay, so it means I did not copy it. Okay, so I want to copy the function. Right, then now there it is. So now we'll call this, it will not be an exponential, it will just be, let's check here. Oh, I did not. Okay, so it means I'll just call this is what I should display here. This is what I should display here. Okay, then now, then the D, it will not be D. I'll just use D1. Let's use D1. D1 here. But now the line graph, okay, let's just say the graph of, it would just be the graph of the cosine function, the graph of a cosine function. Let me just put this here. Let me check something. So it's D1. Okay, this means we can now plot the graph. Let's plot the graph. Okay, so I did not run. You see, now it's showing the warnings. Let me run the warnings also. That must not display those warnings there. I want you to ignore the warnings. Okay, let's run this. Okay, so now we can easily see that, you see that it says that when h approaches 0, you can easily see that it started with the h of 0.5. The more it coming closer and closer to 0, then the function on its own is actually becoming 0. So that is what the limit. So it says the limit when h approaches 0, then the cos of h minus 1 over h, it's becoming 0. So that is what we have experimented now. So without wasting time, let's now do the same for sine. So what I'll just do, let me just copy this so that we can also observe this on the issue of sine. So on the issue of sine, let me just paste it here. So just write this sine function. Then I'll copy this here. Then I'll paste it there. This one, then this will be D2. Then here it will just be sine of h all over h. Then let's now do the running. First of all, I'll compute this just to prove. We want to show that we actually wanted to observe what will be the limit when h approaches 0 of sine h over h. Let's run this program. Now let's compute with 20 iterations. Then you can easily see that when h is 0.5, sine h over h is giving us 0.96. But when we reduce the value of h, is giving us now 0.96, still the same, 0.44, 0.96, 0.42, 0.97, 0.39 is 0. You see now the value of when h decreases, when h approaches 0, then the sign of h is actually approaching 1, it's becoming 1. So let's now run this. You can easily see that when according to this, we can easily see that the limit, okay, let me just use, we can easily see that the limit when h approaches 0, sine h over h, it becomes 1. It's true because look, when h coming closer and closer to 0, the function on its own becomes 1. It becomes 1, but this is a step size function. So now you can easily see that the limit when sine h over h, the limit when h approaches 0, sine h over h gives us 1. So these are the things that we need to know because we'll be using them to prove those trigonometric, the derivative of trigonometric function. So we've seen this practically. Then now we can move on and do the proving, ladies and gentlemen. Okay, let me just save this Python program. All right, let's now go back to our presentation. Now, the first one, we've seen that when the limit when theta approaches 0, sine theta over theta gives us 1. We've seen it, and we've seen that the limit when sine theta approaches 0, when theta approaches 0, cos theta minus 1 over theta becomes 0. Now, ladies and gentlemen, we want to prove why are they saying that the sine derivative of sine theta is equals to cos theta. Let's prove that. ladies and gentlemen. Right, before we prove that, let's write all the information that we just used. Number one, we've seen that the limit when h approaches 0 of sine h over h, this gives us 1. And the limit when h approaches 0 cos h minus 1 over h, this gives us 0, ladies and gentlemen. Now, I want us to prove this. I want us to prove that when we have, let's say we have f of x, if f of x equals to sine x, we want to prove that the derivative of sine x is cos x. This is what it's required to prove. We want to prove that indeed the derivative of sine x is cos x. And to prove that, ladies and gentlemen, we are going to use first principles. We'll use the first principle. Let's do the proving. So we'll say f prime x, or before we use the first principle. Okay, let me just write it here. Let me write the definition just to use it, because we'll be using it. Okay, let me just write it here. According to the first principle, it says f prime x is the limit when h approaches 0 of f of x plus h minus f of x all over h. You have learned this from grade 12. Now we are using it to prove that the derivative of sine is cos. And to do that, guys, we do this. We know f of x, it's sine x. Then now, what is f of x plus h? Obviously, we want these two. So it means f of x plus h means where there is x, we're going to put x plus h. It means this becomes x plus h. But if you look at these guys, this is now a compound angle. This is a compound angle. So we need to use the compound angle for sine. And we know for sine, it's sine cos sine. So it's going to be sine x cos h plus cos h multiplied by sine x. So it means it's sine cos cos sine. So it's sine x cos h plus cos h sine x. So now we're going to write the definition. F prime x is the limit when h approaches 0. But now, what is our f of x plus h? We have it is this one, so I'm going to plug sine x cos h plus cos h, then sine x. Then now what do we have? We have what is this? Let me check something here. Sine cos sine. Okay, sine cos sine. It's fine. Then now, no, something's wrong. So it's sine of x. No, it's supposed to be. No, yeah, I apologize. Something's wrong here. So it's sine x cos h plus cos x sine h. I apologize. Cos x sine h. So which would be cos x sine h. Right, then minus f of x. What is my f of x? F of x is sine x, then over h. And what we'll do here, we'll do this, ladies and gentlemen. We're going to do this. We're going to say the limit when h approaches 0. Look, there we have sine x, and there we have sine x. We're going to group them together. Actually, let's take a common factor between these two only. So this will be sine x into, if I'm going to remain with cos h minus 1, just these two only, plus then we leave this one. This will be cos x multiplied by cos sine h, sorry, cos x multiplied by sine of h, then divide by h. I believe you guys are following. Right. I hope what you understand what I've done. I've taken this and this one and grouped them together by taking a common factor. This is what we've done here. Then this one, it is this part here. So now from here, now we're gonna do this. I'll divide everything by h. So it means this will be the limit when h approaches 0 of sine x into cos h minus 1 over h plus, then put the limit again, the limit when h approaches 0 of cos x sine h over h. I believe you see what I've done. Then from here, ladies and gentlemen, I'll do this. From here, what I'll just do is just to look at the first part. If you look at the first part, you can easily see that here we're speaking about the limit when h approaches 0. So which means if you look at this, because it's h approaches 0, it means sine x, we can pull it out. So it means I'm going to write this and say f prime x. Sine x will be out because it's not the function of h. So it's going to be limit sine x, the limit when h approaches 0. I mean, I'm referring to this part here. So we're going to remain with cos h minus 1 over h plus, I do the same here because cos x is not a function of h. I'm going to pull it out. So I'm going to remain with the limit when h approaches 0 of sine h over h. Ladies and gentlemen, I believe you're following. But if you look at this, guys, look at this part here. Look at this part, this one and this one. It's what we just proved, that to say the limit when cos x minus 1 over h, this is becoming 0. This is 0 and this is 1. So it means where there is, so you can put sine x and we substitute this by 0 plus cos x, we substitute this by 1. So what is the final result? This is 0, ladies and gentlemen, and this is just 1. So remember, you're going to have cos x. So that's why we say the derivative of sine x is cos x. This is the proof. We just proved this. So these things are very important, ladies and gentlemen. They are very, very, very important. What did we do here? We used the compound angles. We use the compound angles, and also we use the principles of limit for sine h over h and the cos of h minus 1 over h. So it's very important to be able to understand that. So we've seen that the derivative of sine is cos. We've seen that the derivative of sine is cos. So now we can prove that the derivative of cos is actually negative sine. So we can prove that the derivative of cos is negative sine. So we've proved the first one. Now we can move on to the next one. So let's just go back and check that. Okay, remember we've seen that the derivative of sine, it's actually cos. The derivative of sine is cos. We proved by using first principle. Now let's prove the second one. The second one of cos. Let's prove the second one of cos by still using the same approach. So now we're going to do this. We want to know, okay, fine. We know if we have f of x, when we have f of x as cos x. So now we can expand this. What is f of x plus h? So it means when there is x on cos, we put x plus h. It's still a compound angle. This becomes cos x, cos h, minus sine x, sine h, cos x, cos h, minus sine x, sine h. So it's cos, sine. So we're going to use the first principle. F prime x is the limit when h approaches 0 of f of x plus h minus f of x all over h. Then we're going to have the limit when h approaches 0 of Then what is our f of x plus h? We do have this. So we're going to have cos x, cos h minus sin x, sin h. Then minus, there's a minus. F of x is our cos x all over h. Then here we can group the like terms. I mean, we can group like here, I'm referring to this. We can look at this one and this. There's something common in it, which is cos x. So we can group them together. So what is the common factor between these two? It's cos x. So if you are pulling cos x out, you're going to remain with what? Cos h with minus with the 1 plus minus. Then this is just standing alone. Sin x, sin h. Then now everything divided by h. Let's split them. The limit when h approaches 0, this will be cos x into cos h minus 1 over h. And we do the same here. We put limits again minus the limit when h approaches 0 of sin x, sin h over h. I just divided by h in both sides. And from here, I have to take the cos x outside the limit, even this one outside the limit. So it means what will going to happen here? Let me just try to erase some of the things here. So now it means if we do that, we'll be having this, ladies and gentlemen, because remember sin x and cos x are not a function of h. So it means we can pull them out. So we're going to have f prime x. So I'm pulling the cos x out. So it's going to be cos x. So I'll remain with the limit when h approaches 0 of cos h minus 1 over h. Same applies, minus sin x, the limit when h approaches 0. So I'll remain with sin h over h. This is what I've done here, ladies and gentlemen. But now we know, and we have proved that this part here and this one, we went through them. So we know that this is f prime x. This will be cos x. This is 0, ladies and gentlemen, minus sin x. This is 1. So you see that this is the final answer. It's negative sin x. So we've proved that. We've proved that the derivative of cos is negative sine. The derivative of cos is negative sine, ladies and gentlemen. The derivative of cos is negative sine. So we've seen that when we have f of x, which equals to sine, its derivative is cos. But when we have f of x, that is equals to cos, then its derivative, it's negative sine. It's negative sine. Ladies and gentlemen, we use the first principle to prove that together with those limits axioms. So it's very, 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 very important to be able to understand what we just did. Now let's now go back. Right, already we have proved that the derivative of sine is cos and the derivative of cos is negative sine. So we have proved these two. And how about if you want to prove what is the derivative of tan and what is the derivative, yes, of tan? According to this, it says the derivative of tan is sec squared. But now, however, to prove the derivative of tan, we can no longer use first principle. We are not going to use first principle. We'll use the quotient rule. Remember, we went through the quotient rule in the previous video. Let me talk about this so that you can be able to understand. Number one, let me remind you about the quotient rule, ladies and gentlemen. Right, then what is the objective here? We want to prove, what do we want to prove here? Required to prove. We want to prove that if f of x equals to tan x, then the derivative of tan is always sec squared x. According to what? that we are required to prove. Now, we're not going to use first principle, guys. We need to use something called quotient rule. I'm saying, yes, quotient rule. All right, let me remind you about the quotient rule. According to the quotient rule, it says when you have y equals to f of x over g of x. Quotient because the fraction. Then it says the derivative of y with respect to x. According to quotient rule, it says if you have this, you differentiate your numerator, f prime, times, you leave your denominator, which is the g, minus, then you leave the numerator, which is the f, times, you differentiate the denominator, which is the g, then everything divide by the derivative, divide by the g of x, but in all squared. This is what we have learned in part 1 of the video. If you have not watched the part 1, kindly, there's a link that I've shared below. Kindly follow the link and try to understand that. So now we want to prove that the derivative of tan is x squared. And how are we going to do that? Look at this, guys. We know, number 1, that when we have tan x, according to what we have learned in grade 12, tan is the same as sine over cos. Tan is the same as sine over cos. You see that it is in the form of a fraction. And because it is in the form of a fraction, we're going to take the numerator as the f, denominator as the g, like what we have done here. And to do that, what is my f of x? My f of x here is sine x. And what is the g of x? The g of x is cos x. And we have proved that the derivative of sine is cos. So we're using that. The derivative of cos, it's negative sine. I believe we are following. I believe you're following, ladies and gentlemen. So now we'll substitute this. We're going to say dy over the x. Now we're using what? We're using quotient rule. What is f prime x? F prime x is cos x. What is g of x? G of x, we have it's cos x again. Minus f of x. F of x is sine x. Times, what is g of x? What is g of x? G of x, or g prime x. G prime x, we have it, that is, it's minus sine x. Divide by, what is g of x? G of x is cos x, but in all squared. Right, then now let's simplify this, ladies and gentlemen. This cos times cos is cos squared x, plus sine and sine, it's sine squared x, divide by the denominator, it's cos squared x. But according to the identities, we know that sine squared plus cos squared is equals to 1. So it means this guy will become 1. So when I say dy over dx, this becomes 1 over cos squared x. And we know mathematically that I wanted to write it some. Okay, let me just write it. We know that sec of an angle is just 1 over cos. Remember, we said the reciprocal of sec is cos. The reciprocal of cos is sec. So very important. So if we know that sec x, it's 1 over cos. How about sec squared? Over sec squared will be 1 over cos squared. So it means you see that this is sec squared. So that's why we know that the derivative of what? Of tan, it's sec squared. x because of this. So it's very important, ladies and gentlemen, to familiarize yourself with the reciprocals. Reciprocals. So you see, I have used the quotient rule to prove that the derivative of tan is x squared x. But how about if we wanted to know what is the derivative of cot instead of this? What if we wanted to know what is the derivative of cot? Let's try to prove it without having to look that side, because we know the derivative of tan it's x squared x. We have proved it. Now, how about the derivative of cot? We know the derivative of tan it's x squared x. Then how about the derivative of cot? The derivative of cot, ladies and gentlemen. Okay? Okay, right. Just a minute. I just want to check something, guys. Okay. Now we want to prove that what is the derivative of cot x. Okay, we know that. Okay, fine. According to the identities, cot is the reciprocal of tan. Obvious. If tan x equals to sine over cos, so it means cot will be cos over sine. So it means we still have the same. We still have a fraction. So since we have a fraction, we'll call the numerator the f, the denominator the g. Or we can use any alphabet. So what is the f here? The f is cos. And what is the g? The g is sine. Let's look at the derivative. Derivative of cos, we know it's negative sine. And the derivative of sine, cos. We've seen that. So now let's do the substitution. We wanted to know what is the derivative of cot. Okay, what is the f prime? Obviously, f prime is negative sine. What is the g of x? G of x is sine minus f. F of x is cos x. G prime x is cos x. Divide by, what is the g of x here? The g of x is sine x. So it's squared. Let's remove brackets. Let's multiply these two. This will be negative sine squared x and negative cos squared x over sine squared x. We can take the common factor at the numerator. It's negative. So we're going to remain with sine squared x plus cos squared x over sine squared x. But we know sine squared x plus cos squared, it's 1. So this will give us minus 1 over sine squared x. But we know that cosec, it's a reciprocal of sine, which is equals to 1 over sine. So cosec is equals to 1 over sine. So, but this one is squared. So it means if you wanted cosec squared x, this will be 1 over sine squared. It means this alone, it's cosec squared, but still there's a minus, so this is negative cosec squared x. So what does this mean? It means the derivative of cot, it's negative cosec squared x. But usually in the exam, they provide you with this, but I just want to prove to you, why are they saying that? So the derivative of cot x, it's negative cosec squared x. I believe you're following. So we use the quotient rule to prove that. We only used first principle to prove sine and cos. But to prove the others, we do not need first principle. We just use quotient rule because we know the derivative of sine and cos. So we prove that derivative of cot x is negative cos x squared x. Let's go and check if that is true. So it's very important, ladies and gentlemen, to know the trig ratios and its reciprocals. There it is. We have proved it. It's just that they are writing it in short. Cos x squared, CSC. This is cos x. So it's cos x squared. You can see it's cos x squared. We have proved it. You can also prove the derivative of cos x. And what is the derivative of sec? So we went through the derivative of sine, cos, tan, we proved it, and cot. Now, how about these two? You can pause the video and try to prove it on your own. And after then you can check the solutions. So here I'm just proving the derivatives so that you are able to know them, not just to cram them, but be able to know how did they get the answer actually? How are they proven? So it's very important, ladies and gentlemen. So we know that the derivative of sine is cos, derivative of cos is sine, and the derivative of cos is negative sine, derivative of tan is x squared x, and the derivative of cot is negative cos x squared x. Very important. Let me prove the derivative of sec and cos x. By the way, just to remind you, we know sine. Reciprocal of sine is cos x. Reciprocal of sine it's cos x. So it means cos x, it's 1 over sine. Sec x, it's 1 over cos. Cot x, it's 1 over tan. Very important. And don't forget, tan sine over cos. Okay? Now, let's do this. Imagine if you wanted to prove what is the derivative of cos x. We do the same. If we say we have y equals to cos x. And what is cos x? Cos x is the same as 1 over sine. You see that I've written this as a fraction. And since I've written this way, it means now we're going to use quotient. This is the f, and this is the g. So I will have to use quotient because this is now in the form of a fraction. You want to prove the first one. Okay, let's do that. So I'm going to do this. I will say I have my f. My f is 1. I have my g. My g is sine x. What is its derivative? Obvious, derivative of a constant is 0. What is the derivative of this? We know the derivative of sine is cos. So we're going to say, okay, fine. This is our function. So we'll just write the definition to say dy over dx, quotient rule. We differentiate the numerator, which is the f, and we leave the new denominator, minus, we leave the numerator, we differentiate the denominator, divide by the denominator squared. Okay, let's now do the derivative. I wanted to prove this. Okay, what is the f prime? F prime is 0. There it is. Times g of x, it's sine x. Minus, what is the f? F, it's 1. G prime x, G prime x is cos x over g of x squared. G of x is just sine x, but in all squared. Let's simplify this. dy over dx. Look at this part, guys. This is 0. So we're going to remain with negative cos x over denominator sine squared x. Look at this, guys. We can work out this. We can say this is dy over dx. This is minus. We can do away with the minus cos x over sine x. Look at what I'm going to do here. Times 1 over. Okay, let me just do this, not to confuse everyone. Okay, I can just divide there by sine x times sine x, which is actually the same as negative cos x over sine x times 1 over sine x. I believe you're following. But guys, we know very well that tan is equals to sine over cos. And cot, it's cos over sine. And we know very well that 1 over sine is cosec. So you see that here we can leave this as a negative. What is this guy? Cos over sine, it's cot. And what is 1 over sine? Cosec. So what does this mean? It means that the derivative of what? The derivative of cosec x is just negative cosec x cot x. So the derivative of cosec, it's negative cosec x and cot x. I believe you're following. I believe you're following. But now, how about if we wanted to differentiate sec instead of cosec? How about if you want to differentiate sec in terms of cosec, ladies and gentlemen? We've seen that the derivative of cosec, it's negative cosec x cot x. It's negative cosec x cot x, according to the proof. Now, we'll do this. Y equals to sec x. We wanted to know what is the derivative of sec x. But we know sec is a reciprocal of cos. It's the same as 1 over cos. Very important. And in that case, this is the f, and this is the g. What is the f? The f is 1. What is the g? The g is cos x. So what is the f prime? Derivative is 0. G prime, derivative of cos is negative sine. Okay? Now, let's do the derivative. F prime, 0. G of x, cos, minus f, 1. G prime, negative sine, over g of x is cos, in all squared. We're going to say dy over dx, this part is 0, and this will be sine x over cos squared x, which is the same as sine x over cos x times cos x. You can still rearrange this. This will become sin x over cos x times 1 over cos x. And we know that sin over cos is the same as tan. Just true. And what is 1 over cos? What is 1 over cos? It's sec. So it means the derivative of what? Of sec is that sec, but with tan. Now, look at this, guys. Derivative of sec, it's sec x tan x. How about the derivative of cosec, by the way? For cosec was cosec x together with cot x, but with the minus. But for sec, it's sec with tan, not with the minus. I believe you're following. So it means the issue of quotient rule, guys, is very important because you see now we're using quotient rule to prove some of the trigonometric functions. We're using quotient rule to prove some of the trigonometric functions. So it's very, 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 very important to be able to know this. So we're still going to use the product rule and the quotient rule when we are solving trig function. But here I wanted to prove to you that the derivative of sec x, it's sec x tan x. And the derivative of cosec x, it's negative cosec x cot x. Very important, very, very important. The derivative of tan x is sec squared x. We've seen it. We've seen it. So it's very, very, very important. The derivative of cot x, we've seen is negative cosec squared x. So this is what we just proved now. So it means we are now going to use this to solve problems. So we have seen that the derivative of sine is cos by using first principle together with the limits. Then the derivative of cos is negative sine. The derivative of tan is x squared x by using quotient rule. Derivative of cosec x, it's negative cosec x together with cot x. We've proved that. Derivative of sec x, we got this sec x multiplied by tan x. We have proved that. And the derivative of cot, it's negative cos x squared x. So it's very, very, very important to be able to know this. So now it means what you are left is to solve problems relating to this, but this will be addressed in the next video. Here I wanted just to introduce the derivative of the trigonometric functions, and actually to be able to know that the derivative of sine is cos, cos is negative sine, and the other. And also to familiarize yourself with what you have learned in grade 12, guys. Remember, it's not about cram, pass, and forget. So make sure that whatever you learned in grade 12, you also remember it, because you'll be using it. Very, 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 very important. Trig ratios, sine, cos, tan, its reciprocal, squared identities, and also the quotient identities. We have seen them, we've used them. So if you have not watched my first part video on the product rule and quotient rule, I advise you, I encourage you to do that. Go and watch the video so that will be easier for you to understand this second session. Anyway, thanks for listening, guys. Thanks for watching my videos. Don't forget to like, subscribe, and give a thumbs up. That would be much appreciated. Thank you very much. Bye-bye.